Okay, welcome back. What I want to look at is purely block diagrams in reference to AM amplitude modulation and FM frequency modulation transmitters. Now, this is information purely if you're going to further or deeper electronics, okay? Certain parts of it might be relevant for the electrical side, but you don't have to know this in that sense, but it may still be useful. Okay, block diagrams, AM and FM transmitters. AM and FM transmitters, right, so an AM transmitter, as in figure 13.8, shows the block the block schematic diagram of a simple AM transmitter. An accurate and stable RF oscillator generates the radio frequency carrier signal. The output of this stage is then amplified and passed to a modulated RF power amplifier stage. Now I'm just going to read this down because you should be able to read this for yourself and see where I am at. Okay. So the inclusion of an amplifier between the RF oscillator and the modulated stage also helps to improve frequency stability. The lower level signal from the microphone is amplified using an AF amplifier before it is passed to an AF power amplifier. The output of the power amplifier is then fed as the supply to the modulated RF power amplifier stage. Okay. Increasing and reducing the supply to this stage is instrumental in increasing and reducing the amplitude of its RF output signal. So by increasing and decreasing, you are altering its amplitude signal at the output stage. Okay. The modulated RF signal is then passed through an aerial tuning unit. Now, I've done this basically in text before the diagram comes up. Hopefully, do a bit of research for yourselves as well. Okay. This matches the aerial to the RF power amplifier and also reduces the level of unwanted harmonic components that may be present. Now you need to remove any harmonic distortions because that will consume power and will cause a massive distortion to the output signal that you're trying to use. Okay. And here's the diagram. Okay. Sorry about that. I don't know if you heard that. Okay. Now this is just figure 13.8, shows an AM transmitter. Okay. And it shows you the relevant stages. So let me just move in a bit closer to it so you can see before. Okay. Okay. Now AM FM transmitter figure 13.9 shows the block schematic of a simple FM transmitter. Once again, an accurate and stable RF oscillator generates the radio frequency carrier signal. Now, as with the AM transmitter, the output of this stage is amplified and passed to an RF power amplifier stage. Here again, the inclusion of an amplifier between the RF oscillator and the RF power stage helps to improve frequency stability. The low-level signal from the microphone is amplified using an AF amplifier before it is passed to a variable reactance element. Now, the variable reactance element you may have seen from one of my videos, the variable capacitor, which allowed you to change the frequencies accordingly by changing the capacitance. The variable capacitance diode, this is using a diode in reverse not bias. Okay, and this is something you've seen I've done already in one of my videos on the channel. Within the RF oscillation tuned circuit. Okay. Now the application of the AF signal to the variable reactance element causes the frequency of the RF oscillator to increase and decrease in sympathy with the AF signal. The final RF signal from the power amplifier is passed through an aerial tuning unit. Sorry about that. Aerial tuning unit that matches the aerial to the RF power amplifier and also helps to reduce the level of any unwanted harmonics components that may be present. As with the final stage of an AM transmitter, the RF power amplifier usually operates at an appreciable power level, and this uses class C to increase efficiency. And class C is something I would have mentioned earlier as well before in one of my units. Okay. Here we have figure 13.9. Okay. I'm just going through it a bit, make sure we can get it all in. Okay. And let me just pull that bit. Alright. Just make sure we can get it in. Okay. Thank you. Now, a tuned radio frequency receive TRF. Tuned radio frequency TRF receivers provide a means of receiving local signals using fairly minimal circuitry. The simplified block schematic of a TRF receiver is shown in figures 13.10. The signal from the aerial is applied to an RF amplifier stage. This stage provides a moderate amount of gain at the signal frequency. It also provides selectivity by incorporating one or more tuned circuits at the signal frequency. This helps the receiver to reject signals that may be present on adjacent channels. The output of the RF amplifier stage is applied to the demodulator, this stage. This stage recovers the audio frequency signal from the modulated RF signal. The demodulator stage may also incorporate a tuned circuit to further improve the selectivity of the receiver. The output of the demodulated stage is fed to the input of the AF amplifier stage. This stage increases the level of the audio signal from the demodulator so that it is sufficient to drive a loudspeaker. Okay. TRF receiver have a number of limitations with regards to sensitivity. Sorry about that. With regards to sensitivity and selectivity, and this makes them generally unsuitable for use in commercial radio equipment. And this is just a diagram showing you how that would be set up. Okay, I'm going to just give you a clear view of it. Okay. You're required to complete this gap handout. For following block of diagrams, you are also required to label them, okay, in full. Again, try doing this for yourself so you can see what you need to be doing, okay? And the information has already been given to you, so look back at what I've just shown you in order to complete these diagrams, okay? I believe that's it, okay? Have a good day. I hope you found this information useful again, and I will continue to provide you with additional information shortly. So have a good day. Bye bye.